Hey, what's up, everyone? What's up, everyone? Welcome back to the How to Learn Data Science in Python at the DataCamp episode number 17. Today we're just gonna keep going with our cleaning data in the Teddy data form, and we're gonna talk about concatenating data. So let's just dive into it.
Data may not come in one monolithic file or table for you to load. For example, a 5 million row dataset may be broken up into 5 separate datasets, each with a million rows. Usually, it's because it's easier to store and share data this way. Other times, you may have a new data file for each day. Time series data, such as stocks, may come in this format. No matter the reason, it's important for you to combine these data so you can either clean a single dataset or clean each dataset separately and then combine them later on, so you can run your analysis on a single dataset. I'm going to show you how we can concatenate data frames in this chapter. When we concatenate data, we can combine two data frames into a single data frame. Notice the row index labels in the data frames we want to concatenate. And notice the row index labels after we concatenate the data frames. They keep their original labels. We can concatenate data in pandas using the concat function. To concatenate our data, we pass concat a list of data frames. Here in this list are the two separate weather data frames. The result would be a single data frame with all of our data concatenate one on top of the other. You will notice that the row index labels of the final concatenated data frame keeps the original row index label. This will have consequences when you want to select rows based on the index label. If we selected all the rows where the row index is 0, we get multiple rows back. Here, I'm using the log slicing method to subset on the row index labels. In this case, the rows we get back represent all the maximum temperature values for a particular date. This may be a useful side effect, but you may want to have consecutive labeled row indexes. To do this, you need to reset the index label. You can reset the index label so they are all numbered sequentially by using the ignore index equals true parameter in the concat function. Here we have two data frames from a TB dataset. One contains the melted data frame. The other contains the parse column data that splits age group and sex. In the exercises, you will practice row-wise concatenation and also see how to concatenate column-wise.
Okay, great. So let's just do the concat. Before that, I just remember concat reminds me in the R you get that like C bound and R bound. Like basically R bound, I believe it's just like row. You have two data frames like bound like this way, and C bound is basically like in the deployer. So you have data frame and another data frame. You just put it like combine them parallel. So this concatenate is more like R bind, kind of like you have one data frame and then you stuck it on top of another data frame. But the preliminary condition, I think, it is your column name should be the same. Otherwise, you probably won't be able to do that. So here we have a three data frame have preloaded Uber 1, Uber 2, Uber 3. I don't know what they are, but let's just look at the head and see what it is. So it's a time lat long base. Okay, let's just concatenate 1, 2, and 3 row cap. Okay, so you get a PD concat, and you are passing through. Let's see. The three data frame here. That's the latest, I believe. If I remember that right. And you're gonna ignore index equals to true. I'm not quite sure the syntax is right. Let's see. Or maybe not. Yeah. Okay. It's not true. P is not true. Okay, here we go. And let's see what we have here. Row concat. Yeah, seems like right. And then you print a shape. So row underscore concat dot shape. Not quite sure. Sure, we have no callable. What's a shape? So sometimes you can just like base that long add or do we have a shape function? Index hello head get. I don't remember the syntax of this one. Okay. Head I remember. C cat dot head. We have a head. Let's see. Let's see what's this next. Dot shape. Okay. Attribute. So it's not the method. Okay. 297 rows and 4 columns. Exactly. So did you correctly define the panda data frame? Did you correctly set the datetime? Express something different. What do you mean? What do you mean by that? Do you correctly define the panda frame? I have no idea what he's talking about. Let's just look at the answer. Concat. Oh, so we don't need to about the index. So like we actually don't want to do that. Okay. You have successfully concatenated the 3 Uber data frame. Notice that the head of the row cat is the same as the head of the row 1. What are you talking about? Do you mean this one? Let's just run first. And print it out. Oh, it's have the same day. Is that what you're saying? Do you notice the head of the concat is the same as head of Uber 1, while the tails of the concat had the same as Uber 3? I didn't notice that. Oh, wait. What do you mean by that? So this is a head, right? Let's just do print Uber 1. Oops, why is jumping on me? Sorry about that, guys. Let's just try to figure out what does that mean. So concat, right? Put in here. Just put the Uber 1. Okay, so it's the same. Why it's the same? Let's continue. Think about the column-wise concatenations data to stitch data together instead of the top of the bottom. To perform this action, you're using concat function, but sometimes keywords x equals 1 before x equals 0 is for the row-wise concatenation. You'll return to the Ebola dataset work with briefly. The last chapter have been preloaded, okay. Melded array, okay. The status of the country the patients contain a single column that have been passed into new column, okay. Ebola study in the shell. Okay, what do you want me to do? Concatenate, melt, and colonize. So you mean one and passing through to a list. So one means column. Let's try pd concat. Right. So that's you guys. We got this melted one, and we get this country, and we have this access equals to 1, so it's indicated to the columns on that, and then okay, seems right, like those two guys over here, and you want Ebola ID, right? Dot shape. Look at the shape. Okay, looks right. 6 column, and look at the head. Ebola ID. Dot head. Okay, seems alright. Nothing special. Let's keep going.
Now let's leverage some of Python's basic programming features with data cleaning in pandas. In order for us to concatenate data frames, they must be loaded and placed into a Python list. We can load each dataset individually if there are only a few datasets to be concatenated. But what happens when there are tens, hundreds, or thousands of files we need to load and concatenate? Manually loading each one is not a viable option. We can use the glob function in the glob library to find files and use a Python for loop to read in all the data files. Globbing is a simple way for Python to do file name pattern matching. We can use various wildcards to specify a file name pattern we are looking for. A wildcard is a symbol that will match any arbitrary number of characters. The asterisk is a type of wildcard that matches any string. Contrast this with the question mark that will only allow us to match one character. For example, asterisk.csv will match any file ending in .csv, and filename underscore question mark.csv will match file underscore and then any single character, then the CSV file extension. This character can be a number 0 to 9 or any letter A to Z. The glob function will return a Python list of file names that match the pattern. We can use this list of file names to systematically load into pandas data frames. Globbing will give us a list of file names. Now we want to load each file into pandas and then add all the data frames into a list. We can pass this list of data frames to the concat function to concatenate multiple data sets all at once. Now let's put the find and concatenation example together. We import the glob module. We use the glob function to look for all CSV files by providing the pattern asterisk.csv. One way we can create a list of data frames is by using a for loop. We first initialize an empty list that we will append data frames to. Then we write a for loop that will go through each of the file names from globbing. We have a list of file names from the CSV files. We will iterate through each of the file names. Each file name iteration we will call file name. Then we can use pandas to load the file name into a data frame. Finally, we can then append the loaded data frame into a list.
Really?
The end result will be a list of data frames from the glob results. We can then use this list to concatenate the list of data frames into a single data frame.
Okay, I see.
Now it's your turn to find and concatenate data.
Let's see. List data, right? Let's take a look on the list of data, right? Here. Import global. Global CSV equals to global CSV. Read everything in CSV file. Okay, here. I see what's going on. So basically, if you guys look at here, he imported the library globe. global and basically global. What is global, by the way? Grab all the CSV or like pattern recognitions, and then you got the CSV file. It's got all those stuff here. So for loop, uh, concatenate this list. That you save everything, appended everything in this empty list, and by this for loop, reading the file names. The file name says over here CSV file. So CSV files over here, loop through, and then pending, and then concat. So now you're going to practice globe mode to find all the CSV file in the workplace. In the next exercise, program and load them in data frame. Then show you the video of the globe module's function called the globe that to take a pattern and return a list. What is this globe do? Python globe. Pass name pattern expression. Okay, so it's a pass name pattern expression. So you grab basically you grab the pattern flag .csv. So everything this white card star with .csv, you grab it. That's kind of like the expression, white expression. So what do we want to do? So first import, right? Import globe, right? Well, what else? And import pandas as PD. And the pattern, what pattern we're gonna grab? So over here, .csv. So everything about CSV, we got that one. So save all the file, match CSV, globe pattern here. Load the second file into that first CSV2. What it means second files. Index 1 to data frame CSV2. What is second file, by the way? Let's run here first. Oh, okay. That's kind of weird because you here. What I'm saying like it's weird because here, index. So here, right? Like here you have that CSV globe CSV. Oh, I think it's globe from the server, and this is the path. Okay, so you don't actually see this like directory, but it's basically loading the pattern for the .csv over here. So we don't need to mark the path over here. Okay, load the second one. So second one, the index should be 1. And yep. So second one, 1404. Correct. Submit. Oh, okay. What's the problem? String object have no attribute of load. So load should be I would say like pd dot read csv. That should be all right. Right. Enter the concatenate all the matching. So now you have the empty list called data frame, right? So everything in the for loop enters for each file names appended that concat for loop through CSV file. Okay, we already have the CSV files over here. Those three guys over here, loop through and pdf equals to read pd.csv, and you basically just like put the loop through all the CSV here, and then like you df append to everything into this empty list frame, and you concatenate it. So if you concat this list, should be like this. Yes. And you have the frame and the shape in the hand. Let's see if it's right. Panda don't have attribute of CSV. Oh, read CSV, what I mean by that. And it should be right. So basically you read CSV, loop through the file names, append it to the data df, right? I think that's the case, what he did over here. Yep. This empty list append the data. And at the end, just cast it. You get the shape, you get the head. Okay, good. Merge. This is like a sequence.
Concatenating data can be thought of as stitching together data that was once a single data set. But this is not the only way data can be combined. Here are two data sets. One of the US states and their population, and the other contains US states and their two-letter abbreviation. If we wanted a single data set that contains states, population, and two-letter abbreviation, concatenating the data sets together will not work. In this particular example, we cannot concatenate the data frames because the ordering of the states are not the same. The last way we can combine data is by merging. If you've heard of or familiar with SQL, then Pandas has the same capabilities to join tables. Merging data allows the analyst to combine disparate data sets based on a common set of columns. We can merge these two data sets by matching observations on the state name and end with a new data set where we have the full state name, the abbreviated state name, and the population all in a single data set. Here, the keys will be the state on the left data frame and name on the right data frame. When we merge on these keys, only the state names that are the same will be matched together to create a new data frame. In order to perform a join, we use the Pandas merge function. You pass merge two data frames, the left and the right data frame. If the columns you want to use as keys to merge on are spelled the same, you can use the on parameter and specify the key. However, in our particular example, the column names are different. You need to specify the left on and right on parameters for the individual keys. You only need to specify the on parameter or the left on and right on parameters. Our merged result has the full state name, the abbreviated state name, and population in a single data set. There are three different types of merges that can occur: a one-to-one merge, a many-to-one or one-to-many merge, and a many-to-many merge. The US state populations example earlier showed a one-to-one merge. The left data frame and right data frame all have a one-to-one corresponding key. That is, there are no duplicate values in each column that we are merging. If there are duplicate values in one of the keys, then the values from the other key will be repeated to fill in the duplicates. There are multiple cities in each state. When we combine the city dataset with the state dataset, the values for the state code will be duplicated for each value in the city. This is the one-to-many or many-to-one merge. These are the same types of merge. It just depends on which order you specify the data frame with duplicate keys. The various types of merges you can do, one-to-one, many-to-one, or many-to-many, all use the same function. The only difference is the data frames you're merging together. Now it's your turn to merge together multiple data frames to create a single data frame, and you'll see what happens in a many-to-many merge when both data frames have keys with duplicates in them.
Okay. So PD merge left is what? Site. Right is visit. Left is on what? Name on the site. Right on the side on the column name. And OPO. Merge. Many to one. What is that? Merge side and visit that. Name from side and visit that visited the previous step. Okay. Merge. Oh no, what's next? Um, left. So left and right name. Merge. Okay, so each name have like multiple dates. I cannot really tell the difference, but name and sign. Okay, so you got duplicate multiply. Okay, makes sense. Many to many. So PD dot merge. What are we gonna do here? Side and the visit. Left on the name. Right on the side. To PD merge. And then left is uh yeah, okay. Survey left on and taken. Oh, okay. Side visit. This M2M looks like that comes reading and then after merged. It's actually already merged. Like survey is like this. We taking person quote reading. So we're here. So here we go. So I hope you guys enjoyed today's episode and I see you next time. Peace.